Okay, welcome to Phishing with Superbait. My name is Jeremiah Grossman. I am the CTO of a company called White Hat Security. This will be a different presentation. I've only done this presentation one other time, so it should be pretty interesting. Normally I do, what I wanted to do with this presentation was to have two computers, one running on each projector, so we could see one computer controlling the other, but we'll be able to do it with one. It'll just look a little haphazard. So a little bit about myself. This is about my 10th time speaking at Black Hat, and this is actually one of my favorite conferences to go to because we get to talk about really high-end things going on in the industry. It's an opportunity to share what the leading or bleeding edge is in information security, some of the high-end attacks, and some of the really complicated stuff like the one before us. What I do in my daily life is I do technology R&D for web application security and different solutions. I'm a frequent Black Hat speaker, and also Black Hat and lots of other conferences, speak for NASA and ISSA and lots of conferences like that. My night job, which keeps me busy even when I'm at work, is founding of the Web Application Security Consortium. It is a body devoted to web application security and pushing the industry forward with standards and with cooperation amongst everybody in web application security, from the vendors to the users, developers, and so forth. And previously to founding White Hat, I was an information security officer at Yahoo, where I was the so-called hacker Yahoo for about 2 years. And my eminent domain there was 600 or so websites in 42 countries and about 180 million users. And learning about that environment, what web applications really means as a whole in, when you really get out there. A little bit about my company. We do remote scanning of websites. We schedule scans and run continuous scans on websites, publicly available websites. We find the vulns and relay the information to customers. So all I do all day is hack websites and tell customers how to fix it. That's what we do. So what are we going to talk about today? We're going to talk about, of course, phishing with Superbait and what exactly does that mean, or what do I mean by it. We're going to cover current web security models, phishing and cross-site scripting, some hybrid attacks, some of the very, very high-end cross-site scripting attacks, and also best practices. In your books, there's a lot more slides than what we would be presenting up here. We'll do the demos, which will cover most of the material, the slides that I took out. And so we'll lay the groundwork on the current security models. A lot of you might know this material, but it's good to understand the basic models, what they do, what they don't do, and because we'll be circumventing them all, everything from SSL to the same origin policy, and so forth. So what do we have out there as far as web security goes? What are we, the users, how are we protected? Well, the current marketing jargon out there says SSL secures everything. We can shop at the websites because they have SSL on the website secure. We have browser security to some extent. We'll go into the same origin policy, some other things. And we also have the on the horizon but not yet implemented and already controversial two-factor authentication that's coming to the web. So just to blast through a couple of these slides on what SSL is and what it does and what it does not do. First and foremost, SSL encrypts the traffic between point A and point B. But SSL does not, contrary to what the websites tell you, SSL does not make a website secure. If a website has a vulnerability in it, the data is not protected. Simple as that. Okay, probably preaching to the choir here, but SSL really does not make a website secure. It only secures the data in transit. SSL sites have been hacked using SSL just as much as the ones who don't. All right, same origin policy. Now this is quoted verbatim from the Mozilla website, and it's a little confusing, but we'll go into what it means. The same origin policy prevents documents or scripts loaded from one origin from getting or setting properties of a document from a different origin. Now, this is an interesting historical point because this is actually where the term cross-site came into play, where back in the mid to late 90s, different web developers on rogue websites out there, you would land on a particular website and they would load up frames to other places and have JavaScript read into those other frames, hence the cross-domain. And they implemented the same origin policy soon after. So if the site was being delivered from domain 1 it couldn't access data from domain 2. So this is a brief example here. So this page here, this blue box, has some code in it, and it's being delivered in the white up there on the top of the box under the domain1.com context. The source in the actual page itself is loading up 2 additional iframes, one to domain 1 and the other to domain 2. Below it, in the JavaScript, there is the x1 and x2 variables. Now what happens is when the first one's loaded, when it gets executed, it will reference the domain 1 site, the domain 1 iframe, and that's okay because they're on the same domain. But what happens is when the second code, where it goes by iframe 2 and tries to reference it outside the domain context, it gets denied. And if you're familiar with the console messages in Firefox, this is the message you'll get. You'll get a permission denied. So that's the same origin policy in action, preventing script in one domain from accessing data in the other domains to protect cookies and data from other sites. So we have that. Then we have two-factor authentication, and we have online banks rolling it out or saying they're going to roll it out. Even AOL says they're going to roll it out. And it's my contention that my prediction, many others will be trying it out or trying to force it upon us to use these types of two-factor auth, thinking that they're the solution to all our problems. But I'm here to tell them that they're not. So Bruce Schneier has already spoken a little bit about two-factor auth, and that this solution it will not solve the problems we have today. He says two-factor authentication isn't our savior. It won't defend us against phishing. It's not going to prevent identity theft. It's not going to secure online accounts from fraudulent transactions. It solves the security problems we had 10 years ago, and not the security problems we have today. So that's his words. So I'll go into a little bit more about why that is a little bit later with the demos. So, laying more groundwork, what is the phishing scam? So this is the traditional, we see this a million times a day in our inboxes. The phishing scam is really just the high-tech version of the age-old confidence scam, where somebody approaches me on the street, tries to convince me there's somebody that they're not, and proceeds to try and con me. That's really all it is. So when we have the normal phishing scam, it works something like this. We're familiar with it. We get an email. And in the email, we says, dear eBay user or eBay member or something like that. And might even have some kind of security policy saying, according to my site policy, blah, 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 do something and click here. And they're taken to a page that says, please fill out this form. They might have your PIN number, username, and password. But it's different from the real site. The domain will actually be different. They'll use IPs or some kind of URL masquerading. They'll use lookalike domains, but it's not the real website. Now, what's important to remember is that phishing attacks traditionally don't occur on the real website, okay? So that's how we're able to spot them. That's how we're able to detect them, is that they're not on the real domain. It's not the real website. It's merely a clone. So after the users filled in their data, it's shipped off to the attacker, credit card data, social security numbers, usernames, passwords, and they profit. So that's the normal phishing scam. All right, so how else do we get how users get taken in by phishing scams? Well, they get, of course, the email, the instant messages, message board postings, guest books, blogs. There's lots and lots of ways, the criminals are able to communicate to us and try to get us to do something or visit a web page with some nefarious content or from, cloned content. So some quick stats, some quick trends out there from the Anti-Phishing Working Group. Number of phishing attacks reported is over 2,500 now as of January 2005. It's growing at 28% between July and January. That's 2004. The number of brands hijacked by phishing, 64. The average time for the site that's online, the cloned website or the phishing website, is 5.8 days. And the longest one they've seen is over a month. So there's some basic stats on what's going on out there and that the problem is growing because it seems to be effective. All right, so we know phishing. We've seen some of the browser security models, and a lot of us have seen, well, all of us has probably seen cross-site scripting at least referenced somewhere. We see it on BugTrack daily, many, many times. and to the point where a lot of us get nauseous seeing it. But it is dangerous. It is underestimated as far as its power goes. But JavaScript is really what makes cross-site scripting bad. It's become a very, very powerful language. If you've seen Google Maps or Gmail, you know the power of JavaScript. It can do lots and lots of things, both for good and for bad. Cross-site scripting itself is by far the most common vulnerability that we see out there today. When we do assessments on websites, cross-site scripting is easily number one. It'll appear on 90% or more of the websites out there, and usually not just one. It'll occur in multiple instances. So it is also, it's a little small, I apologize, but the cross-site scripting is also part of the OWASP Top 10. It's part of the Web Security Threat Classification. If you don't know about it, learn about it. There's plenty of resources all over the place, but I'll explain how cross-site scripting works and how it and what it's capable of. So when cross-site scripting executes, what JavaScript itself, even if you take the exploit out of it, you just talk about JavaScript. JavaScript has complete access to the document object model. What that is when you look at a web page, it has complete access to all the text, all the images, all the forms, all your cookies. It has access to everything as part of the what you're looking at in the browser. You can, using JavaScript, you can alter the content, or cross-site scripting, you can alter the content of news articles, change the actions of forms and where they point to, et cetera, et cetera, et cetera. Lots and lots of stuff, and we'll get into some demos. And for users, when you've been cross-site scripted, it's very, very difficult to detect that you've actually had it, because a cleverly written cross-site scripting attack is not going to leave any trace, and it's more or less invisible. So there's two types of cross-site scripting. There's type 1, direct echo is one of the many names for it. It's the most common variety of cross-site scripting. The thing about this one is it requires the victim to click on a link to be exploited. So you might get an email, or somebody might ask you to click on a link, but to be affected by this one, you must click, which makes it the less severe of the two. When they click, the JavaScript code executes. So at a basic level, this is how it works. So, or how a scenario might work. An attacker sends an email to a user containing an email with a specially crafted link. That link has a host name of the victim's website in the domain. Okay, so let's just, we'll pick on eBay for the time being. So you'll have an eBay host name, and it will have a bunch of JavaScript code tacked onto the end of it. But a user looks at it and goes, looks like it's from eBay, has a domain, it's eBay, probably is eBay, let's click on it. So what happens is the code in the URL there, the one highlighted in red, it gets sent to the server and gets echoed back as part of the page content, okay? It now becomes part of the page and executes in the domain of, well, in this case, victim.com, or if we want to pick on eBay and continue to do so. So the JavaScript code executes. Now, the script can do lots of things, and the most notorious one that we see cross-site scripting, at least examples of it, is a cookie theft. So the document.cookie is an object that'll give you the cookie string, and what the exploit will do is send an off-domain request, usually an image, and tack the cookie data onto an off-domain image request. So you beat the same origin policy in that way. Okay, so you take the cookie data, you put it onto the end of an off-domain request, and off you go. You get all the data that you want. And in the logs, on the hacker's logs, what he'll see is his log entries, makeshift web server logs, and the cookie data tacked onto a GET request in his web server log. So now he has the cookie data. So all he had to do is create this link, get a user to click, and he gets the cookies. What does that mean? Well, if the user's logged into that system, he can then reuse the cookies and become them. Okay? Pretty simple, straightforward. So here's the second variety, HTML injection. This is the one that does not require a user to click. It just auto-executes, and here's how a lot of times it will work. We'll pick on Yahoo Mail, for instance, but this will happen on message boards, guest books. Any place where user-submitted content becomes part of the actual page content, hosting user-supplied data, this becomes a problem. So in this case, the hacker would send HTML email to a Yahoo user or Yahoo Mail user, laced with JavaScript code of some kind, and when they read the email, it will execute inside the browser. So, and the same attack occurs. It will grab the cookie, put it onto the end of an image, a new image DOM object, and off it goes to the hacker where they can pick it up and reuse it. So it's the same attack, but but the requirements for execution are less. So this is the real dangerous cross-site scripting vulnerability out there. So what can we use all this stuff to? And I keep promising the demos, but they'll come. So we can steal cookies, hijack sessions, execute unintended functionality on the website. We can harass users with malicious code, alter any portion of the web page, deface or DOS the website, or violate the same origin policy, or aid in phishing. So what have we seen out there? So phishers right now are just using the garden variety simple phishing attacks. But what we have seen them start doing with eBay or SunTrust Bank or some of these other examples here is that they're starting to use cross-site scripting, a website vulnerability, to leverage their attacks to make them to seem more real. So the genie is out of the bottle, so to speak, that the attackers are using this because the scam looks more effective. They're not clicking and going to a cloned website. They're staying on the same website, which makes it that much harder to detect. So here's the two varieties of what we're seeing those particular hacks work. They're doing two types, the cross-site scripting redirect disguise, and I'll explain it, and also page rewriting. So let me go into the redirect. So this is a quick little excerpt here from a report by the Anti-Phishing Working Group. So they have been seeing these types of attacks. So let me read it here. During the month of January, WebSense Security saw a number of attacks using cross-site scripting to redirect URLs from popular websites in order to better present themselves as a means to prevent blocking. An example of this attack was discovered utilizing the Lycos search engine. By crafting a URL, the hacker can redirect any end user through Lycos directory to a fraudulent web page. And here's an example below. And the URL in there, it is a lycos.com domain. It is legitimate, but on the end, you see WebSense Security Labs on the end. So what happens is, and I'll show it to you, the user gets sent a link with the right domain, the one they're expecting, and on the end of it, there's a domain that the hacker will have them redirect it to. So what happens is when you click on this link, it goes to the server, and the first circle is see the request go out. And the second red circle is the redirect that they'll go into. So in this case, they'll be redirected to B of A in this case, but they can redirect them to wherever they want. So the initial link looks real, but they'll land on a fake web page and a fake domain. So this is the Achilles heel of this attack. It just makes it a little bit more real. So we are seeing this happen out there, but it is getting a bit more real. If any time I'm like talking way too fast, raise your hands and ask questions and stuff. It helps you slow down. Anybody have any questions so far? All right. So page rewriting, here's the second one. We're not redirecting them anymore, and I'll be demoing this right off this slide, actually. So this is the more convincing one. This uses the cross-site scripting type 1, which rewrites the page. So they click on the link, the code gets loaded into the DOM environment, and let's say for the sake of argument, it will update the form where forms post to. So let's imagine a login page where somebody emails them a link from PayPal Security to say, please reset your password on the system. Send you a link, they click the link, and the link redirects where that form posts to wherever they are, okay? And I'll show you an example of this. Okay, you have to give me a second here. Okay, might be a little bigger on the screen. But okay, so this is, I set up a blog software on my laptop here. This is why I was supposed to run on 2 machines. But I set up a real simple blog software here. It has 3 entries. And this is the actual victim website, the one we're going to be cloning. Okay? Now, what we're going to do here is we're going to log into the management end. And good, I'm already logged in. Okay, so this is the management portion of the blog. We can add new entries, make new entries. We have all the back-end functionality here. So let me pull up some code. This is always the dangerous part of doing live demos and presentations. You know, nobody can't help myself, but Mr. Murphy has my number, believe me. All right. All right, so here is one of the admin screens. And one of these parameters up here is vulnerable to cross-site scripting, meaning you can put data in here and it'll echo back to the screen and unfilter for HTML tags, as what good security would indicate. So let me pull out and find where the vulnerability is, because I cheated. It's in the type parameter, and I'll show you how this works. So we'll put in, how about a little U tag first, so something will underline. Can everybody see this somewhat okay? Okay. And we'll hit enter and see what happens. All right. Nothing happened. No. I'm sorry? Oh, it's the wrong parameter? Type. Oh, type. Good. That's funny. All right, so we see right here, see this little indicator here? A lot of times we'll use alert to pop up a JavaScript alert, but if we see the test that we entered wrapped by 2 U tags, that's how we know cross-site scripting happened, because the HTML rendered in the page. Now what happens if we do something a little bit more sophisticated? And I have my little cheat sheet here taking advantage of the actual vulnerability. And in the URL here, if you notice, is that I put in a script tag. Now the script tag sources in code from something off an off-domain source. It's still on the same box here, but it's running on a different web server, but on port 8,000 rather than 7,000. So we'll see if we'll toss this in and see if it'll work. So what this code does, it will actually deface the web page. What we want to do is, so this is what I've shown on this page. This is the normal web page. Now we're going to deface it. Great. The host names aren't working. So it's still going to localhost, but on a different port. So the point is that JavaScript can be sourced in from just about anywhere. Okay, why is it not working? Oh, I know. The code is not correct. Because I normally have 2 computers doing this. All right, so here's blackout, why not? So if we look at the host name here, we're still on the actual host name, so we'll jump over and we'll go to 127.0.0.1. So this is the actual web page. So this is the host name here with the port. So if we look at the defaced website, it's identical. So using cross-site scripting, we've defaced the page for that moment in time. So for that user or for that administrator, we have hacked the web page. Okay, we have not altered any files on the web page or performed a defacement in the classical sense by altering files. We have just simply rewritten the entire web page. So that's not too subtle, but it is funny and effective. All right. So what if we got a little bit more sinister? What if we went, let's try to steal their password, for instance. So I might have to change some code here to go to localhost rather than the other computer. Okay, so once again, that was the normal web page. That's the normal URL. Okay. Now, we'll put in the hack again. Typing in localhost far too much. All right. So hit enter. All right. Now, this is similar to the defacement hack, okay? But we got a login screen. So what this code is, what we pulled in, this is the code here that we pulled in. This rewrites the entire page to make it look like a login screen, okay? It's still on the same website, it's just a new login screen. Now, to the user that thinks, okay, you know, they might have got an email that says update your software or change your password, or you know, something, anything to convince them. And they'll think, okay, I got to, you know, to do whatever this thing says, I have to type in my username and password. So they go, okay. Now, before I type in my username and password, no, wrong one. This one here. This is the server that's actually, we're tailing the access logs to it so you can see what happens. This is the off-domain page running on port 8000. So when I put in my password, I can't see it, and hit login. Now, everything worked fine. They're now in the admin console. They saw nothing. Nothing happened. Everything worked fine. But if we go back, where is it? There we go. On the off-domain server, okay, in the URL, because we sent it off domain, my username and password is actually in there. Okay, so I'll show you how it worked in the code, what we actually did. So this is the form. All the code here is the form. Okay, that's all the cosmetic things that we did. In the code here, what we've done is, the first thing we did is steal username and password, and we grabbed the strings from the username and password field, and we sent it to the steal function. The next thing we did was submitted the form with whatever they sent in. We sent it to the right server. So if we look in the action here, it just sends, you know, to localhost here to empty CGI. So if we look at the steal username and password function, what it did was it just used the common trick. You make a new image DOM object, and you set its source attribute to something off domain. Notice the port 8000 here rather than 7000. You can make it whatever you want as long as, you know, they're online, the user's online, so you can make it go wherever. And you tack on the username and password. So that gets shipped off domain first. They log in, and everything works beautifully. Nobody saw a thing. Okay, so that's how something more subtle would work. But cross-site scripting really doesn't end there as far as, I'm sorry, go ahead.
Yeah, how would that work on the secure socket layer? If I got that sent to me in an email, you know, knowing that I log into my bank normally, you know, by using SSL, how would that work? Would that function correctly?
It would function perfectly. It would, I think, depending on the browser, yeah, you're probably right that if I'm using yeah, you're right. I think if I'm using some non-secure content, I wonder what would happen if I use an SSL server as the target, you know, two different.
But then what you have to do is, like, use JavaScript to set your location, right? Say, okay, sure, HTTPS, you know, your site serves up with SSL, just tag on HTTPS, bam, it's happening, right?
You might have to play some trickery to get around some of the browser pop-ups, but you just set an off-domain secure server, and you might be okay. But you know, at the end of the day, if you know the user, you know, something pops up and says something's insecure, they're probably going to click OK anyway.
They'll say some of the content's not secure. You want to see
Yeah. Yeah. So there's I'm probably the biggest culprit of that anyway. So. All right. So we have the defacement. We have password theft, which is more indicative of the cross-site scripting, you know, of the phishing scams that want usernames and passwords. So let's go one step further. Let's try something you know, a bit more insidious. We're going to try a spoof. So this one here. Okay, so I'll probably have to rewrite this stuff as usual. All right. Now Now this will go real quick, so I'll try to get to it real fast. Okay. So down here, if you notice in this iframe here, I might have to change the code to update. But this hack here opens up an iframe, okay? It will open it up to a particular URL on the same host, on an on-domain host, okay, to perform some action for me. So let's just reload that. Did it work? Did spoof get sucked in? No. Yeah, spoof got sucked in. Okay. So something's going on. Oh, do I? Ah, very good. Thank you. Somebody else debugging my code. Okay, so I think 127.0.0.1. All right, so let's try this again. 127.0.0.1 pulls it in. Good. Huh. Well, let's check this out real quick. Was working a second ago, wasn't it? Wasn't this blue before? Huh. Let's see. Oh, down here, over here? Oh, yes, you might be right, yes. No, it's just a URL. 127.0.0.1. Okay, I think what's happening here is something with the blog that's set up incorrectly, but this should still work. So it's still setting up, but why is it not connecting? So let me... apologize for the delay. I'm going to grab that. I'm going to pull the source down from the other location to make sure I have it right. So it's going in, okay. Localhost, it's good. Ah, there we go. Operator error. All right. So maybe that's not working. .1, 7,000. I apologize, it's just not wanting to work. What that should have done is when you execute that, it will auto-post a blog entry. So right when they click on that link, it would auto-post a blog entry to the blog, and it has another nice Stallone picture on it. But so JavaScript has the ability to perform actions on behalf of the user. So it has that power as well. So a couple of quick demos there to show you how phishing can use cross-site scripting to make itself more believable. So let's jump back into the slides. We'll have one more demo a little bit later, but let's cover a few more things. So we have all this stuff. All right, so let's do some of the higher-end cross-site scripting attacks. So this stuff has been experimented out there in the wild by other people besides myself. Case in point, Anton Ranger, who I've been in contact with, has done some really good work on it. And a lot of the concepts are based on it, but not all of them. So I'll be able to demo that here. So what are the current limitations in cross-site scripting that we have? One, that victim attacker connection is not persistent. So once they're cross-site scripted and once they click off, the hacker no longer has control. So they lose control. And the off-domain data mechanism, how they transfer, is only one way, only from the victim to the attacker. Traditionally, the attacker can't send data on the fly back to the user. Okay, so we're going to try to solve that particular problem. So the goals of the exploitation of this, given that it works, okay, is that we want persistent control of the user. Excuse me for a second. We want persistent remote control with the browser. We want to keep constant control over the user, even if they click around. Okay? We want to be able to monitor several cross-site scripted users all at the same time, and we want to be as invisible as possible. Okay? And we want to, as a result, circumvent just about every web security mechanism out there that we have. Bold claim, I know, but it's Black Hat, and if anybody disagrees, question me. All right. So I can go into how it works, but I think I'll just do that after. I'm just going to go right into the demo, and we'll cover exactly how it's working in more detail. So let's just pray that it works. Now, I want to do a little bit of setup here. Now, so just to reiterate, on port 8000, we have the blog. On port 7000, we have the blog. On port 8000, we're hosting cross-site scripting content. And what I'm going to do is start, what the heck is this? It won't bind. Huh. Probably have to change that code real quick. We're going to bind something to port 9000. All right, so we have something listening on port 9000. This is our controlling server, and I'll bring up the controller right now so you can see it. See, all the host names. All right, so this is the controlling server, so you'll be able to see this in action. This is where the cross-site scripted user is going to send data to, and this is how we'll be able to monitor the user. Now, let's bring up more code. We have the server up. We have this one here. So we're all using the same cross-site scripting vulnerability, just with different code. So let's paste this in here. So we'll hope that it works. Oop. 1, 2, 7. That's right. That's it. Numlock or something. All right, so let's grab this string. Great. All right, so let's. Where? Where? Oh, did it? Very good. Okay, everything should be functional. Let's hope. I think it worked. Now, what you're seeing here is a cross-site scripted user. Now, I'm going to try to make this browser screen. I can't. Here we go. Now, if everybody can see the red bar at the top, there's also one on the right and one on the left. This is a visual indicator that the user is trapped in an iframe. Okay, what's happened here is that when the user got cross-site scripted, the DOM was deleted. Okay, I then made a new iframe that's ballooned to the full width of the page and put a red border around itself so we could see it. The location of that iframe was set to whatever the user was expecting to go to. In this case, the admin screen. Now, what I want you to see on the back end here, okay, this is where the off-domain data should be going to, okay? Now, I'm going to try to put this off to the side and click this. Now, you see all the hex data? What that is, when the user clicks and jumps, okay, the HTML that they're seeing has been passed off domain in chunks, just how we did all the other stuff. It has passed off domain in chunks. And if you notice the polling requests, that's the cross-site scripted user going, do you want me to do anything? Do you want me to do anything? Do you want me to do anything? And so forth. Now, if we reset the controller, we can see we have trapped a user, they're running a unique session, and we can see what they are seeing, minus the style sheet, okay? Now, we can see what they're seeing. Now, watch. So right now we have Phishing with Superbait on the screen, so remember that one. So we'll go to like entries or something. Okay. Oh, still owned. It is in there. See the titles? Now, see? We are watching. So they're on port 7000. We're on 9 watching them. So no matter what they do, where they go, we can track them. Now, it would be very, very easy to, you know, the border is set down below, but we could remove the border and they would never see it. We could constantly track them no matter where they go. So imagine for a moment that we can spawn new iframes that are invisible, okay? So we could try a couple of these. Now, on my local host here, let's see here, in this JS file, the user is bound to 3973. Now, if I reload the page, you'll watch it. It'll grab another session. Okay, so now we can monitor multiple users at the same time. So we can grab in, jump in there. Okay, now we're watching 9732. Now, JavaScript on the fly, we'll just make it very simple. Alert document.cookie. We will be real quick, and we'll wait a second. We'll go to the users. So what we're going to do is command the browser, okay? So save. And it executed in their environment, okay? So now we got persistent control, bidirectional communication using JavaScript. Think of it as kind of like a JavaScript Trojan horse, okay, without an install process, okay? So in the code here, so we can really do whatever it is that we want. So if we'll pull up, anybody know some cool JavaScript? Now, let's see here. Let's see. Do I want to open my mail client? Oh. So we can, let's see, what commands do we want to send? I should have had this all pre-made. So how about var HTML equals now.
You want to send cool JavaScript to the browser?
Yeah.
When iframe source equals C.
Gotcha. Let's try this. Watched.content window, how about .href. Mouse is acting up now too. Equals, how about 127.0.0.1, and how about colon 7000. We'll just send them right there. See if that works. Come on. Why are you not working? Should work. It's trying to connect. What do you want to try to do? But, well, case in point is we have persistent bidirectional control. Any commands, any JavaScript we want to send to the browser now, we have a channel to do so. So they're perpetually in this environment. So let's click over here back to Phishing with Superbait. We'll update here. Now if we want to make them go to here, copy link location. Let's try that. Throw that in there. Maybe that'll work. Looks like it's trying to connect, doesn't it? For some reason it's not going. heck's going on? Jeez. I told you live demos are the curse. Anyway, so now we have this JavaScript aware environment here, and so we have total control. Now,
is there a real world example on why you would want to control the user's browser, other than irritation that I'm sitting there and all of a sudden an alert pops up or I get redirected somewhere?
I think that's more just a matter of creativity, really. So if you cross-site script them and they happen to be, well, on their blog site, so we can walk them through, using an invisible iframe, we can walk them through a change password process or a blog entry process. If they happen to be on a bank, we can make them transfer funds. And you know what the interesting part is? Every log in the world would say that they did. I mean, there's no trail. Every log in the world, the request originated from their browser, from their account. It was not stolen. I don't have their password. They did it. I mean, we can get really nefarious. We can make them do illegal acts. We can make them hack other websites. We can make them download child porn. We have complete control over that browser environment until they close the window. So.
Wouldn't the logs on the remote web server indicate in the URL that site?
In the URL, yeah, the victim website's logs would have the data where you sent it to, but that might be just some kind of, think GeoCities or something like that. It's just a spot to put files and such, so they would have that data and a place to go to. That's right.
Is there anything keeping you from doing this
Over post? I mean, getting somebody to click on a post and then doing it that way?
Well, there's that, but the whole boxing stuff, you do that over the post.
Oh yeah, you can make them send any request you want in any way you want. It might, depending on the browser, it might alert, but oh, go ahead.
So that whole session, as long as that browser window stays open, even if I go up to the address bar and type something different, I'm stuck in that iframe.
At that point, if you manually changed it, you would break out.
You would break out.
Yeah.
So the same would be true if I right-clicked and said open up, spawn a new window,
If you spawn a new tab, that tab would not be in control. That's right.
or an entire new browser.
Yes, but depending on the domain where that's in, they could control if it's in the same domain or something like that. So if you went right-clicked, open a new tab, I think you'd be able to control that tab provided it was in the same domain.
So as long as it stayed within the same DOM, they'd be able to control the second spawn.
Other windows, other tabs, other whatever. Yeah.
See, it text as you're showing or obviously mostly JavaScript based, but I'm wondering if there's any changes or if there could be attacks functional in XP Service Pack 2, the Internet Explorer version that's in Mac, given some of the work that was done to harden against these types of things. Do you think still working?
It's just JavaScript. I'm not exploiting any browser vulnerabilities. It's just working as expected. As far as the browser is concerned, that data came from the website. So there's no vulnerability here other than the cross-site scripting hole. There's no OS hole, IE hole, or whatever. It's just the way it works. I'm sorry?
The vulnerability is purely created by the web server. The original one, not
Right, yeah, it's, what all web application security breaks down to is improper input validation,
So you can also programmatically in the script as well, very carefully, make yourself out of the
Yes, I'll get to that one actually. There are tips and tricks you can do for your website to help your users, but the real problem with cross-site scripting, I'm a user just as much as everybody else is that cross-site scripting, we tout the solution is to fix cross-site scripting on the server, but that means you're putting me as a user in a position where I have to depend on the security of a website to protect me. There's no client-side security for any of this. There's nothing I can do, other than eyeball a link, and, I might be able to do it because I can do this stuff, but, the Joe user's not going to be able to do that. They're just going to see a link with a bunch of crazy characters in it and looks like every other link. All right. So we'll blaze through some of this so we can see some of the technical background for how this works. All right. So what happens is the JavaScript will scrub the current DOM, overlay an iframe over the entire viewport, and fill that frame with the content what the user was expected to receive. I put in some code in there. I just disabled it for the talk to do keystroke capturing. We can capture keyboard events for whatever the user does, and we can pass those off domain 2, just like every other piece of data. And the way that bidirectional communication works is the JavaScript will create new script tag DOM objects and keep polling to the off-domain server going, I need a, source equals, and it'll make a source. So when we write to that file, it'll automatically get sucked into the user's DOM. So the trickiest part was actually getting massive amounts of data, lots of HTML, off domain. I mean, you can do it with simple cookie strings. I mean, it's not that much data, but when you're talking about, an 8,000 byte web page, it gets a little bit more trickier. So this is the code here. I won't go through it all, but this is the code here that monitors the iframe. So when it changes, we know. Okay, so that's the code that does that. All right, so data capturing. So, So more code on how we grab data. So we capture keystrokes. We can gather up cookies in HTML. We saw that on the console. We had the cookie in there. And then what we do here is we take all the data. I take all the data and I chunk it up. And I think I use 2,000 byte blocks or 5,000 byte blocks, whatever will reasonably fit in a URL. And I chunk it up, base64 it, and send it off domain. That's what you saw in the logs, is big chunks of base64 HTML content, and I put it all back together on the website to display it. So we can track all the movements. So it just explains more of that. So this is the control server I'm using. It was just a quick web server written in Perl, and it's just blasting off chunks of web pages off domain. So we have bidirectional communication. We've seen this. It bypasses the majority of the same origin policy. So the same origin policy says I shouldn't be able to read cross-domain or send off-domain. Clearly we can. The only part we haven't been able to circumvent with JavaScript in the same origin policy is we can send requests to any location off-domain. We just can't read it back. Okay, so we can execute functions on any server. We just can't read the data. So that's really the only protection we have on the same origin policy right now. Okay, that same feature also prevents us from utilizing web service and stuff out of the browser, but that's a completely different topic. But we do have bidirectional communication with the server for commands. So what have we done? I mean, it's neat to look at. It's fun to play with, and it's good for inter-office jokes and things like that. But well, clearly SSL isn't going to stop this. We've seen two-factor auth where we're interacting with the website. They're going to ask you for token, username, password, token. We're on the real website, so that's still going to work. We're still going to be able to track it. For those of you who read the news on Bank of America's use with SiteKey on the images, it's still going to work. It's still the real website. And so there's not a whole lot we can do except kill cross-site scripting to prevent this. How am I doing on time? What do I have? 5:45, so I got 15 minutes. Okay, so we'll leave about 5-10 minutes for questions and such. So this is the common stuff we go over. How do you fix cross-site scripting? I'll just blast through this. It's real easy. It takes 2 lines of code. The data I send in there, it'll be less than and greater than signs 9 times out of 10, 99 times out of 100. If you simply scrub these characters and HTML encode them before they're echoed back to the screen, you will not be vulnerable to cross-site scripting. The code will take you 2 lines if implemented properly, or maybe even 1 line if you're a better regexer than I am. So here's some code snippets for the Perlers like me and the PHPers unlike me. So here's some code snippets for you to use and improve upon if you like. This is how you fix cross-site scripting. The regex here on the top takes the data, pulls out all the nefarious characters, and encodes them with their proper HTML encoding. These are more, the Perl ones are more blanket. They'll take out just about everything that's high order ASCII. All right, so what else do we have besides in the code? We have, on the Apache side of the house, we have mod security, which does have facilities to prevent less than and greater than signs in, provided by the sec filter at the bottom there, prevent cross-site scripting attacks. It will prevent or stop less than and greater than signs from being passed through on the, I believe, the query line or the URL line. The problem is sometimes web applications have a need for allowing those characters, so this gets to be problematic. It's sometimes one of the problems with application firewalls in general. But if your site is not supposed to be receiving those types of characters on the URL line. It's a good filter. You turn it on, and it does a lot of good. On the Microsoft IIS side, and again, we've probably done 100 websites in the last 3-4 months, and we've noticed a lot of IIS 6 stuff. And I got to say, I've never been a huge fan of the Microsoft products or company for that matter, but the .NET stuff, IIS 6, it's really good. We find a lot of, we don't find as many vulnerabilities in that system, like cross-site scripting and SQL injection, as we do on other systems, because the default configs prevent the single quotes, the semicolons, the less than and greater than signs by default. We find vulnerabilities in those systems, like I said, where they become problematic and they turn off that config for website functionality reasons. So IIS has that stuff built in. If you can keep those configs turned on, by all means do so. If you're not running IIS 6, there's also IIS Lockdown, URL Scan, and Secure IIS by EI, and those will all help you prevent this problem. They all have facilities to prevent cross-site scripting and SQL injection. Now, to the gentleman's question about frame busting code. Now, this was normally used to prevent abuse from people encapsulating websites in frames. But I found that that this is actually a really good technique to prevent the phishing with superbait hacks, the one where I encapsulate the iframe, is that this code here will actually make the web page explode out of the internal iframe and come full screen, okay? I've actually not been able to figure out a way to, if that code is actually in the originating web page, I haven't been able to figure out a good way to stop that behavior from happening. It doesn't hurt a web page to put that in there. You just slide that one liner in there, and it's a lot safer. It's a bitch to get around, believe me. And that's it. All right. Thank you very much. Questions?
One way to think of that the web browser can be either improved or recalled in order to
There's lots of ideas out there. I could probably bend your ear for an hour, but has been ideas, but nobody takes the problem seriously enough to do anything about it, really. So, but because it's one or two people got to do something about it, Microsoft or Firefox. I could program some kind of module, but no one's going to use it. So, any other questions? All right, thank you, everybody.